Today I'm going to show you how to make a fully 3D printed thrust stand just using a basic 3D printer. If you want to build this yourself, I've put free STL files in the description below. Start by loading the parts into your favorite slicer. I'm using Creality Print, but you can really use whatever you want. Just make sure you set the wall count to at least 4 and the infill to around 35%. Also set the infill pattern to cubic. For the part of the foot peg, you'll want to enable support since it's printed in the upright position. Once everything's sliced, you can start printing. This print takes a really long time, so it's probably worth getting it going overnight. For filament, I am using eSun PET G. It's tougher than PLA, handles heat and vibrations better, and it's still easy to print. If you want to use the same stuff I did, I have a link to it in the description below. Assembly is pretty straightforward, though if you want more details, I have included a link to the full 3D model in the description below. I also recommend using a carbon fiber rod or arrow to help reinforce the stand if you plan on testing any big motors on it. Also, I just find it helps getting everything to line up correct. First, start by gluing parts 1 and 2 together. I use CA glue, but you can also use epoxy or super glue. If you plan on using arrows with this, you can usually cut them by using a razor blade, but if you're using a solid rod, a Dremel tool is going to be your best bet. Though I find if you put the rod in a drill and carefully press with a razor blade while it's turning, it usually cuts it pretty good. Next, continue with parts 3, 4, 5, and 6. After those are dry, go ahead and bolt your base plate on. In the future, I'll be releasing plans that you'll be able to mount your smaller motors such as 2207s or even 1406s to this stand. But I made this version this size because I need to thrust test my 5065 400 kV motor that we'll be using on our 10-foot A10 project. When mounting the top parts on, it is critical that we get this straight. If not, we will get uneven pressures and it might even affect our readout because the force isn't being applied straight to the scale. If you're using a carbon fiber rod or arrow and you want to use it for future projects, be careful not to get the glue on the shaft, otherwise you'll have a pain trying to get it out and have to carve off all the glue, which is not a fun task. When gluing the middle vertical joint, be particularly generous with the glue here, as this is the weakest section in the whole build. That said, this stand is incredibly strong and will stand up to pretty much any motor you throw at it. For screwing on the base plate, use 4mm bolts and make sure they are nice and tight so your motor has something nice and secure to mount on. For this version, you'll want to use M3 screws to mount the motor. For other motor plates, I'll size the holes for whatever screw size is standard for that motor range. Our stand is done. Overall, it's pretty strong and I'm really pleased with how it turned out. Now it's time to mount our prop and go give it a workout to see how strong it really is. For this test, we have a monster 5065 400 kV motor that spins a 16x8 prop on 6S, which is 25 volts, which if you are new to the RC hobby is the upper end when used in RC planes. To see how many watts and amps we draw, I have wired in a power meter between my motor and battery. To mount the thrust stand, I just screwed it down to a deck board with a couple of deck screws and set weights along the outside edges. In my stand, I forgot to add holes into the design, so I have to drill them. That is corrected along with some other things such as holes where you can insert a piece of 3D printer filament to make alignment easier when building. During this test, the setup produced about 1000 watts of power and about 10 pounds of thrust. This is a huge amount of thrust and vibrations, and I was quite impressed on how well the stand stood up to the test. If you like this video, make sure to give it a thumbs up, and if you'd like to see my upcoming videos on my first 3D printed plane and a 10-foot A10 Warhog, make sure you subscribe so you don't miss it.